Hello again. Today we're going to start our unit over one of the most important skills from Algebra 2, which is going to be factoring. So before we can get into factoring, we need to make sure that we know our operations. So a polynomial, okay, means many terms. It means you're going to have one or more terms. So an example of a polynomial could be like 3x plus 2x squared. Okay, so these are two separate terms. This is x to the first power. This is x to the second power. This is actually what's called a binomial because there are two terms. Okay, so if you have two terms, it's called a binomial. If I were only to have 5x to the third, only one term, this is called a monomial. If I have three terms, so if I have, 3x squared minus x minus 2, in three terms, this is called a trinomial. Anything else, you would just say a polynomial of 4 terms, or a polynomial of 5 terms, a polynomial of 6 terms, and so on. All right, so the one that has one term is called a monomial, and that will be our focus today. All right, so monomials, operations with monomials. Let's see. Adding, subtracting, multiplying, and dividing. So if you're ever adding or subtracting, that means that you're looking for like terms. So what I had in my examples there, I couldn't add or subtract anything because they were unlike terms because the variables had different exponents. But if you have something that's like 5x minus 3x, don't forget you can combine these. These are like terms. You have x to the first power, you have x to the first power. So you keep the same variable with the same exponent and just combine the numbers out in front. 5 minus 3 will give you 2. Now, when the exponents change, that's when we're not going to just be adding or subtracting. That's when we're going to be multiplying. So for example, if I had the monomial, 2x to the third power times x to the second power. Well, first off, treat your coefficients as coefficients and treat your exponents as exponents. Okay, we are multiplying. If we were adding this, we would not be able to do this problem, but we are multiplying, so we're able to do this. So I'm going to treat my coefficients as coefficients. So the number in front of this x to the third power is 2. The number in front of this x to the second power is 1. So I'm going to multiply those together. And then my bases, so x to the third power times x to the second power. All right, so 2 times 1 would just give me 2, but my bases, I have x to the third, which means x times x times x. And then here I have x to the second, which means x times x. So when I'm multiplying it all together, I have 1, 2, 3, 4, 5 x's. That's x to the fifth power. The shortcut, when you are multiplying with the same base, the exponents, you need to add those together. All right, so 3 plus 2, that's why I get 5. Likewise, if I were to do this problem, let's say I have 2x to the third divided by x to the second, I could rewrite this as 2 times x times x times x over x times x. The way a fraction works is you cancel any common factor on the numerator and denominator. So we have a common x on top and bottom, not just one, but we have 2. So what we're left with is a 2 on top and an x on top, which means we actually don't even need the fraction bar at all. So shortcut for that, we got 2x to the first. The shortcut is if you are dividing and you're working with the same base, you're going to subtract the exponents. Let me clear my page and I'll come back. Now let's look at an example where we have a powers of powers. So I was doing 2x to the third before. Let's still do 2x to the third. But what if we raise all of this to the third power? Well, remember what this exponent means is I'm taking the base, and since I have all of this in parentheses, it means all of this is the base. I'm taking it to the third power. So what this means is I'm taking 2x to the third times 2x to the third times 2x to the third. I'm taking the base and multiplying by itself 3 times. So 1, 2, 3. So now I'm going to separate my numbers and my bases. So my numbers out in front, meaning my coefficients. So I'm taking 2 times 2 times 2. Those are numbers, so treat them like numbers. 2 times 2 is 4, times 2 more, that would give me 8. But x to the third times x to the third times x to the third, that means I'd have 3 x's, and then 3 x's, and then 3 x's, which means I would have 9 total x's. All right, so the key for this one is treat numbers like numbers, so you'd still take 2 to the third power, but then you're going to take x to the third, and parentheses, those mean multiply. And since your numbers are only separated by parentheses, that's your shortcut, is multiply. Something else we need to discuss are negative exponents. So let's start off just with an example. So let's say if we have 3 to the first power. So 3 to the first power means 3 just by itself, it's just 3. But 3 to the second power means 3 times 3, which is going to give you 9. And if you have 3 to the third power, that means 3 times 3, which is 9, times 3 more, which is 27. Okay, so then if you want to do 3 to the fourth power, you take 3 times 3, which is 9, times 3, which is 27, times 3, which is going to give you 81. So notice here, as we just keep increasing our exponent by 1, every time that we're going this way, we're just multiplying by 3. So 9 times 3 gives us 27. 27 times 3 gives us 81. But what if I do this in reverse? Okay, well, if I'm doing this in reverse, that means instead of multiplying by 3, if I'm starting off with 81, if I'm going in reverse, that means I'm going to divide by 3. Going in reverse, I'm going to divide by 3. 27 divided by 3 gives me 9. 9 divided by 3 gives me 3. The reason why I'm talking about going in reverse is because what if I ask you what 3 to the 0 power is? So pause it. Think about that for a minute. What is 3 to the 0 power? All right, welcome back from pausing it. I hope you came up with the right answer. Going in reverse, you could work this through. So 81 divided by 3 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. Well, going in reverse, because I just want 1 less for your exponent, means divide by 3. What is 3 divided by 3? The answer is 1. All right, anytime you have a number that is raised to the 0 power, it's going to be equal to 1. Well, besides the number 0 itself, but we're not getting into that today. So take any other number, raise it to the 0 power, and that is going to give you a value of 1. But we can do even more than that. What if we go into negative exponents? So 3 to the negative first. Once again, we're taking our exponent, we're going down by 1, which means we need to divide by 3 again. So 1 divided by 3, that's just a fraction, 1/3. What is 3 to the second power? Negative second power. I already did 3 to the second. What is 3 to the negative second power? Well, divide by 3. What is 1/3 divided by 3? Well, remember to divide with fractions. You keep the first fraction, you change to multiplication, and you flip the second power, or the second fraction. So that's going to be 1 over 3 times 3 is 9. So that's going to be 1 over 9. All right, so notice a very similar answer for the 3 to the second and 3 to the negative second. This was 9, this was 1/9. Okay, what a negative exponent does is it takes the base and only its base, and it moves the base to the opposite part of the fraction. All right, so 3 was being raised to the negative second. Right now, 3 is in the numerator. Negative moves it to the denominator, leaving us with a placeholder of 1 in the numerator. 3 to the second power is positive 9. All right, so 2 important concepts here. Take a number to the 0 power, it's equal to 1. Negative exponents, take the base, move it to the opposite part of the fraction, change the exponent then to positive, and actually simplify, evaluate. All right, so now we're going to put all of these operations together. So this is going to be kind of challenging, honestly. You'll have a harder day with today than you will with the operations with polynomials. Simplify until there are no parentheses remaining. You can't have any like bases in a term. Make sure there are no negative exponents. Make sure there are no 0 exponents. And if you have any like terms, those need to be collected as well. Remember to treat numbers like numbers. So those numbers out in front, those coefficients, treat them like numbers because they are numbers. Versus your exponents, treat exponents as exponents. All right, so here's an example of a monomial. We have 4x squared. This is called a quadratic monomial because it's being raised to the second power, hence quadratic. Monomial because it's a single term. Now, note, only x is being raised to the second power. Had we put parentheses, now your base is 4x. Okay, but only x is being raised to the second power. Okay, so I just used a keyword right there, a vocab word. This is what's called your base. Whatever you're raising to your exponent, right there. And then this number out in front, it's not a part of the base again because we don't have the parentheses. This is called the coefficient. Okay, so if you type it into your calculator, -3 squared, and you don't include the minus sign as a part of your base, meaning you don't put parentheses around it, your calculator is going to tell you that this is -9. And you're going to say, well, -3 squared is -3 times -3. That should be +9. But what your calculator is doing is it's taking how you wrote it and following order of operations. So it's taking the base, which is 3 only, because 3 is the only one that's attached to the 2, the exponent. So 3 is the base. 3 squared is 9, and then negate that, -9. Versus this is saying all of this is raised to the second power. So -3 times -3, this is +9. All right, now we're going to do a couple of examples, and we'll be done with our notes for monomials. Doesn't matter where you start this problem. You can start and simplify inside your parentheses first. You can take care of the negative exponent on the outside. There are multiple ways, but however you get there, you still should arrive at the same answer as me at the end. All right, so I think what I'm going to do first is I'm going to start off with parentheses. I'm going to start off inside the parentheses and simplifying. So simplifying in parentheses, if you want to write it this way, you could write it this way. A squared means a times a, and then we have a b. A to the -3rd. Well, a negative means that you're going to take the base, which is a, and you're going to move it to the opposite part of the fraction. So I'm going to take my base a, and it's in the denominator. It's going to get moved to the numerator. The negative is what moves it, so now I have a to the 3rd in the numerator. And then b squared is b times b. All right, so rewriting this, I could have a times a, and then I have a times a to the 3rd power, which is a times a times a, and then I have a b. Denominator, oh, I should not forget this. I have a -2 on the outside. Denominator, I have b times b. So now I'm going to cancel any common factors on top and bottom. So I have a b on top. I have 2 b's on bottom. I'll cancel it with one of them. Nothing else to cancel out. All right, so what this is going to give me is 1, 2, 3, 4, 5 total a's on top. So a to the 5th power over, there's a b on the bottom, all raised to the -2nd power. Another way I could have done that is without writing it all out like this. A to the -3rd, I still have to remember, takes the base and moves it to the opposite part of the fraction. So that would have been a to the 3rd. But then I have a common base. So if you have a common base and you're multiplying, you keep the common base and you take the exponents and you add them together. So 3 plus 2 is how I got 5. Versus with your division, we have a 1 minus 2. Okay. The larger base is on bottom, so that means the base is going to stay on bottom. And so really do 2 minus 1, which will give you to the 1st power. And then we still have this -2 exponent. Okay, so what the negative exponent does is it takes the base and it flips it. So we have our base, all of it's in the parentheses, so we're going to flip our fraction around. So this is going to become b over a to the 5th power. The negative is what flipped it, so now it's just raised to the +2nd power. So now we're taking b to the 1st to the 2nd, so that's b to the 1st to the 2nd over a to the 5th to the 2nd. What this is going to give us is we're taking powers of power, so we're going to multiply. So 1 times 2 is 2. That's going to give us b to the 2nd power. And then a to the 5th to the 2nd is going to give us a, and then 5 times 2 is going to give us 10. So final answer, however you did it, you should come up with b to the 2nd over a to the 10th. All right, last example problem. Treat numbers like numbers. So we have a 4 out in front, we have a -5 out in front, we have parentheses, we have no sign in between, which means implied multiplication. All right, so that means we are going to be taking 4 and we're going to be multiplying that by -5. The next part of our monomial that I see has a base of d. So that's going to be, we're going to take d to the second power and we're going to multiply that by d to the first power. So what I'm doing is I'm finding like bases. And since we're multiplying, I'm just rearranging them. The order that you multiply doesn't matter. I'm rearranging them to write them next to each other. So then we have t to the 5th times t to the -3rd. And then we have v to the -4th times v to the -1st. And then we have z to the 1/3 times z to the 1/3. Treat numbers like numbers. So our number out in front, 4 times -5 is -20. Now, taking your like bases, you are going to treat exponents like exponents. And since we're multiplying, we're going to add. So d, and then 2 plus 1 would give us d to the 3rd power. 5 plus -3 would give us t to the +2nd, because 5 and then plus a -3 is 5 minus 3, which is 2. And then we have v to the -4th, v to the -1st. So -4 plus -1 would give me -5. And then z, and then 1/3 plus 1/3 is going to give me 2/3. Only other thing I can do with this is I have a negative exponent. I'm not allowed to have negative exponents. So what a negative exponent does is it takes the base and it moves it to the opposite part of the fraction. So right now there isn't a fraction. You can think of this all over 1. So right now v is in the numerator. Everything else is going to stay in the numerator. The only part that moves is the base that was being raised to the negative. So v is the only part that moves. The negative is what moves it. So now it's going to be raised to the +5th power. And there would be our final answer.